Today's notes are going to look at solving two-step inequalities. So for our first example, we have negative 4b minus 5 is greater than negative 25. And I'm going to solve this just like I solve a two-step equation. So I'm going to look at the side with the variable, and I want to cancel out the number that is not using the variable first. And that would be the minus 5. To cancel out the minus 5, we're going to add 5 to both sides. And that's going to leave us with negative 4b is greater than negative 20. My next step is to cancel off the negative 4, so I'm going to divide both sides by negative 4. And then that will leave us with b, negative 20 divided by negative 4 is a positive 5, and then I need to make sure I flip that inequality sign because I'm dividing by a negative. So b is less than 5. Right, so to plot this, I'm going to put an open circle on 5, and then my arrow would point to the left. Right, you try this one on your own. 2x plus 4 is greater than or equal to 24. All right, so for this one, you should have gotten x is greater than or equal to 10, and that would have been a closed circle on 10 pointing to the right. For our next example, we have m over 3 minus 3 is less than or equal to negative 6. So my first step would be to cancel out the minus 3, so I will add 3 to both sides. That will leave us with m over 3 is less than or equal to negative 3. And then to cancel out the m divided by 3, I'm going to do the opposite and multiply both sides by 3. And that will leave me with m is less than or equal to negative 9. That would be a closed circle on negative 9 pointing to the left. All right, you try the next one on your own. So the work for this is shown. You would subtract 1 first, and then you would have multiplied 7, and you get 21 is less than n. And if I rewrite that with the variable first, n is greater than 21. So open circle on 21 pointing to the right. Next, we're going to look at inequality word problems. And these are some key words that you are going to see. So I highly recommend copying this table down in your notebook so that you know which inequality symbol to use when you see these keywords. So our first problem says Daniel had $25 to spend at the fair. If the admission to go to the fair is $4 and rides cost $1.50 each, what is the greatest number of rides Daniel can go on? So a couple of things to note here. So Daniel has $25. Admission is $4, it's $1.50 per ride, and then our variable would represent the number of rides. So now let's think about this. If Daniel has $25, that means that whatever he spends at the fair has to be less than or equal to $25 because he can't go over that amount. Now we have to look at what's going to cost him $25. So the $25 is going to come from the $4 admission and $1.50 per ride. So now if I want to put this in equation form, I'm going to say $4 plus, and then it's $1.50 per ride. So this is where I'm going to have to use my variable. So I'm going to say $1.50, and I'll just use R here to represent the number of rides. And then it's going to have to be less than or equal to 25. All right, next we're going to solve this inequality, and I went ahead and wrote it with the variable first because that's typically how you're going to see it. So now when I'm solving this, I'm going to get rid of 4 on both sides, so that means that I need to subtract 4, and that's going to give me 1.5r is less than or equal to 21, and then to cancel out the 1.5, I'm going to divide by 1.5, and that's going to give me that r is less than or equal to 14. And then letter C says to explain in words what your answer means. So our answer would mean that for $25, Daniel can ride 14 or fewer rides. Our next problem says the dance committee of Pine Bluff Middle School earns $72 from a bake sale and will earn $4 for each ticket they sell to the Spring Fling dance. The dance will cost $400. All right, so let's pull out our important details. Right, so they've already earned $72. The dance will charge, or they'll charge $4 per ticket for the dance, and then they'll need $400. So if they need $400 for the dance just to be able to host it, that means that they need greater than or equal to that amount. So they need at least $400. So now we're looking at what's greater than or equal to 400, and that would be the $72 that they've already earned and the $4 per ticket. So to write this in equation form, I'm going to say 72 plus 4, and I'm going to put a variable there because it's per ticket, so I'll say 4t is greater than or equal to 400. Now in question B, I'm going to solve this, so I'm going to subtract 72 from both sides. And then I'm going to divide both sides by positive 4, right? And when I do that, I'm going to get t is greater than or equal to 82. So then question C, explain in words what your answer means. So the dance committee must sell 82 or more tickets for the dance. All right, so you try this one on your own. Debbie has at most $60 to spend on clothes. She wants to buy a pair of jeans for $28 and spend the rest on t-shirts. Each t-shirt costs $8. All right, so for your inequality, you should get 8x plus 20 is less than or equal to 60. All right, next you're going to solve the inequality. You should have gotten x is less than or equal to 5. And then for C, explain in words what your answer means. So Debbie can buy 5 or less shirts with the $60 she has.